Looking at some review problems. We've got functions f of x and g of x. We want to calculate f of g of x and g of f of x. Well, to get f of g of x, we go back to the f of x, and we replace x by g of x. So that this x gets replaced by g of x. We have x cubed, so we'll have quantity g of x cubed. Now, of course, g of x is 4 to the x, so that gives us 4 to the x cubed. And that's more or less a sufficient result. However, this can be simplified using the laws of exponents to 4 raised to the x times 3, because a to the b raised to the c is a to the bc, or 4 to the 3x. Also, as we've seen recently, that could be expressed as 4 to the third to the x. 4 to the third being 64, that's 64 raised to the x. Now, I'd love to see it simplified down to this. This is pretty much sufficient, but I really want to see at least this step for full credit. Probably just a point penalty if you just got it to here. But we really do want to get things to simplified form. And this form is more or less optional, but desirable. Okay, anyhow, g of f of x. Well, we take the g of x and we replace x by f of x. So we get what? If we replace this x by f of x, we've got to replace this one by f of x. So we get 4 raised to the f of x. And that is then f of x being x cubed, 4 raised to the x cubed power. Now that's different than this. This says we raise 4 to the x and then cube it. This says we cube x and then raise 4 to that power. So there's a big difference actually. So for example, if x is equal to 2, 4 to the x cubed would equal 4 squared cubed, okay? And that is 256. No, it's more than that. 16 cubed would be 4,096. That would be 4 to the c, 4,096. Whereas 4 raised to the 2 cubed is 4 to the 8th, which is 2 to the 16th, which is 64,000 something. I don't want to think hard enough to think about what those digits would be, although it wouldn't be that hard. Okay, so completely different results if we just follow the order of operations, just for x equals 2. And for almost any value of x, these will be different. Okay.